you might want to think a little more about lighting. Okay? Yeah. Okay.
What is this?
Wait, somebody said square and somebody said quadrilateral. So how many people think it is square? How many people think it is quadrilateral? It's both. Both. Okay. All right.
What is this?
Quadrilateral. But not a square. Is it a square? Is it also a square? Oh, it's both. Yeah.
I don't know whether the sides are
What does it look like is what we asked.
If you have questions, you can always ask. If you need some information before you can answer, you can always ask us. Okay. Yeah. So everybody agrees that they're both squares and quadrilaterals. Yeah? Well, hold on. We can't say? Why not?
because nothing is given about it.
Thing is?
Nothing is given about it.
Oh, you can't, he's saying you can't simply look at this and fair enough, so you want to give them some information before they make a decision.
Okay.
What do you want to know?
What do you want to know?
All the sides and all the angles and the sides.
Okay. Let's see, this is 15 and this is 15 and this is 15
Square.
Oh, you have to give them information about the angles.
all angles are equal.
Square, okay. What was your question? Somebody there raised a hand.
About the other figures, the information is given, then it is clear that it is a rhombus or a chi.
So, but mother didn't give you the information about that. Is there some information that you want to know about the other guy on the left?
Yes.
You want to give the same sides and angles?
Sides and angles.
And all angles are equal.
Square? Okay.
Okay, what about this? But you didn't want any information on that? Because a lot of people said rectangle without any information. What information do you want? Sides. Okay, Madhav, you have to give them sides and angles. Okay.
Yeah.
Once again, all angles are equal.
Rectangle. And a square, of course. No. That's a rectangle, a quadrilateral, and a square, right?
Yeah.
No? Oh, for a square, all the sides have to be the same.
And for rectangle?
Wait, I have to write it down. Okay. What's a square? All sides are equal and all angles are equal.
Opposite sides are parallel.
Opposite sides are parallel. Is that sufficient for square? Okay. And rectangle?
All angles are 90 degrees.
Angles are equal. Opposite sides are equal. That's it. That's all that is needed. Opposite sides are parallel.
On the square, you may want to add that the diagonals are equal and they bisect each other at 90 degrees.
Yeah, let's keep it simple. We need to understand this first. Yeah, you guys know much more geometry than any of us. So this is getting very complicated. And wait, there in that one, the adjacent sides are not equal, right? The one of them in that rectangle? 20 and 10? They're not equal. Okay, so adjacent means next to each other. Right? Adjacent sides are not equal.
Not necessarily, because square is a rectangle. So in a square, adjacent sides are equal.
Yeah.
The only properties are opposite sides are equal and the angles are equal. And angles are equal, which is also there in a square. So square is also a rectangle.
But you said this is not a square.
No, but rectangles are not squares, but squares are rectangles.
Okay, but when I was in school, I remember distinctly that I was told that a square is not a rectangle. And
Square is a rectangle.
why should I believe you? Suppose I was in your school. Yeah?
Because the properties match.
Because of the property?
Match.
Property match. Yeah, mine is also matching because I'm going to say adjacent sides should not be equal. This is what I was taught. And if I were in your school, I would teach you that rectangles are not, squares are not rectangles, right? If I were a teacher in your school and you are my students, I'm a teacher here at IISA. Alright? If I were in your school and I teach you that squares are not rectangles, and I give you textbooks that say that squares are not rectangles, you will be sitting here and saying that squares are not rectangles. Is that right? So now there's a problem between.
Yeah.
Why
should we believe one or the other?
What is your opinion?
I thought squares are not rectangles.
Yeah.
Yeah, that's what I assumed. Because that's a square, that's a rectangle.
That's right. It's obvious that a square is not a rectangle. So how do we decide?
Who's right?
Okay, I'll tell you a very easy way of deciding. You have to believe the person with the greatest weight. Doesn't that work? It needs solution. Okay, let me try something else. You have to believe the person with the greatest gray hair. So how do we decide this now? Yeah.
By seeing the properties of both the quadrilaterals.
So we have the properties.
Yeah.
But the adjacent sides are not equal is not a property of a rectangle.
But I'm saying it is. And notice I have gray hair and I have far more weight than anybody sitting here. You can measure me. Oh, combined thing doesn't matter. And anyway, your opinion doesn't count. Why? Because you're students, right? Students have to listen to teachers. And if I'm a teacher, then you have to say, believe whatever I'm telling you. Is that right? If there is a conflict between a teacher and a student, who is right? Wow, okay. Okay, so that's what you're facing now. Here are two teachers who think differently from you, and you have to convince us that your position is better than ours. All right, how will you do that? So what that means is this: to convince us, should we use the word argument?
Yeah.
Give reasons for why you think.
Easy.
Yeah.
So, rectangle is just a special type of parallelogram which only has its adjacent angles congruent.
Mm-hmm.
So, if we have the adjacent angles congruent, that is, parallelogram has adjacent angles which are supplementary. So, the adjacent angles will be 90 degrees.
Okay.
So, we can call that a rectangle. And square is a special type of rectangle which has a property of adjacent sides also being equal.
Yeah. Okay. So what you said is something like this. Let's see. Shall we write it down?
Yeah.
Okay. You are saying.
Okay, shall we erase this?
Yeah. We don't need the pictures anymore. Okay. There are two positions. Position A, which is what you're saying. A parallelogram is a quadrilateral. A rectangle is a parallelogram, right?
Yes.
And a square is a rectangle. This is what all of you are saying.
Yes.
Now what we are saying is, yeah. Hold on, one moment. Wait, is that what you want to do? I want to say that quadrilateral paragrams are, so now we have a difference of opinion.
Okay.
Why don't we have one opinion?
Okay, that's
A parallelogram is not a quadrilateral. Well, let's finish this, then you can, wait, hold on for a second, 1 minute. A rectangle is not a parallelogram.
not a parallelogram or a quadrilateral.
Yeah, that's true. And the square is none of those. Okay, now that's what we are saying, and this is what you're saying. Right.
A parallelogram should be a quadrilateral.
No, we are saying no.
But because quadrilateral should have 4 sides and the angle should sum up to 360 degrees. And parallelogram has those properties.
A quadrilateral, the angle should be 60 degrees?
360 degrees.
Sorry, wait. What about the angles of a quadrilateral? All the should be 360. Okay, the sum of everything should be 360 degrees. Can we accept that? Okay, that's fine. No problem. We accept that. But we are still holding that a parallelogram is not a quadrilateral. Why are you saying a parallelogram is a quadrilateral?
Because it has 4 sides and its angles sum up to 360.
So for us, this is a parallelogram. And
That is a quadrilateral. Make it slightly, yeah. But the top one is not a quadrilateral.
Yes, it is a quadrilateral.
We are saying it is not, and you're saying it is. What's the big deal? You have to tell us why you're saying that. Yeah.
A quadrilateral is a closed figure with 4 sides.
Yeah.
And a parallelogram is also a closed figure with 4 sides.
Fine,
so,
but
so they both are.
both have some properties, but a parallelogram is not a quadrilateral.
No, but it is a quadrilateral.
But look, you haven't given me any reasons for doing that. Can you come up with reasons for why you think?
so you're a male human, he's a male human, you're not the same. He's
Yeah.
not a type of you.
Yeah.
Quadrilateral is a big type. It is a big type, and under it the parallelogram, the square, the rectangle come.
So like, I am bigger than you, so you are part of me. Sorry. Yeah. The question that we are raising is this. Question that we are raising is, look, let me put it this way. We also believe that a square is a quadrilateral, like you. We are not. But what we want to find out is, what are the reasons for arriving at that conclusion?
Because quadrilateral is a closed figure which has four sides and the sum angles are
That is true about rectangles as well, and we are saying rectangles are not quadrilateral, so there are some differences. The fact that there are similarities does not mean that a rectangle is a type of quadrilateral, does it? So what are the reasons for believing that, is the question. Yeah.
There is a principle known as principle of transitivity, where if A is equal to B and B is equal to C, then
A is equal to C. Good. Okay. So how does it work? Should we deal with that or should we?
How does it work here?
Yeah.
a parallelogram means the properties of a quadrilateral is satisfied by the properties of parallelogram. So parallelogram is a quadrilateral.
Not really.
Only by your definition.
Yeah, because a quadrilateral has to have four sides and the opposite angles should not be equal for a quadrilateral. That's my definition. Why is your definition better than mine? So the question to ask is, why is it bad to define quadrilaterals by saying that opposite sides should not be equal and opposite sides should not be equal? That is why you have defined it, right? I'm defining it differently. Why is one definition better than the other?
So you're saying that is a quadrilateral.
This one?
Yes.
Yeah, this fits the
Now,
opposite.
if you take the same quadrilateral, just increase the size of the small part and make that equal to the other side.
Yeah, but I have defined quadrilateral saying the opposite sides should not be equal. If you make them equal, it will become a parallelogram. All right.
Then it's no longer quadrilateral.
Yeah, it's not a.
Actually, it's alright because a quadrilateral means it has to have four sides and it has four sides, and if its angles sum up to 360 degrees, it's a quadrilateral.
Yeah, but that is true about both. This is true about rectangles as well, and it's also true about squares. But I have added the condition that for a quadrilateral, the opposite angles and opposite sides should not be equal. Yeah.
How can you say that a square is a quadrilateral?
Square is not a quadrilateral because for a quadrilateral, the opposite sides and opposite angles should not be equal.
You just said that square is a quadrilateral.
Yes, you just
Did I say square is a quadrilateral? Sorry. Who said that?
You.
Oh, that was a mistake. Yeah. That was a slip of tongue. Yeah.
We can prove by passing a transversal to the parallel.
Sorry?
We can prove that by passing a transversal between the parallel angles.
The only way you can prove that is by assuming that a square is a quadrilateral. Should we proceed to give an indication of how that can be done? Okay. We have created enough anguish in you, and I told you that we don't really believe what we earlier said, right? Let's make that clear. Yeah.
Sir, you are saying that in a quadrilateral, opposite sides are not equal.
Yeah.
But are you also saying that the opposite sides should not be parallel?
Yes. Opposite sides should not be parallel. You will get that effect. I mean, you don't have to say that separately. You will get that effect. But yeah, absolutely. Opposite sides should not be equal. Yeah. But that is a position. Yeah. Should not be equal, parallel, all that stuff. But we'll now briefly indicate how you can choose between.
I have a question. But
Yeah.
why do you believe that the opposite angles of sides should not be equal in a quadrilateral?
Actually, I told you that we don't really believe it.
Yeah, but even
Yeah.
now, when you're asking us the question, why
Yeah.
do you?
Just to give you trouble. So when I asked you about things like electrons and neutrons and stuff like that, did you think I really didn't know? It is true that I was sleeping in class, that is true. But that doesn't mean I didn't know. Okay. Yeah.
the statement can be contradicted by another statement.
Yes.
So how can we believe in a statement?
If a statement can be contradicted by another statement, that is a good question. How do you choose between them, right? So if there is a contradiction between these two, some people saying that a rectangle is a quadrilateral, and others saying that a rectangle is not a quadrilateral, how do you choose between the two? Very important question. This is the kind of question that you have to keep asking throughout your school, after your school, until you die, after you die. Yeah. All right, so here is a way of approaching this question. How do you choose between classifications? In one classification you say a quadrilateral, a square is a quadrilateral, and the other one you say a square is not a quadrilateral. Shall we draw the pictures? Yeah, the hierarchical structure.
Okay, I'm going to use Q for quadrilateral.
Did you understand that? Yes. Okay. So this is the position that you took. That a square is a rectangle, which is the parallelogram, which is a yeah. But there are rectangles which are not squares, and there are yeah. Here, on the other hand, this is not this is not this, and so on. They are all distinct. How do you choose? Is the question. Okay. So all these are polygons, right? Yes. You can't write P anymore.
So you believe that they are polygons?
I'm shifting gears now. So the question is, what is a polygon? Polygon, a closed figure with three or more sides.
That's a polygon.
Why not? It's a closed figure. And there are 4 sides. Oh no, 3 sides.
It should have straight lines.
It cannot have
So let's fix this.
You have to change your definition.
straight line.
Okay, a closed figure, let's say bounded by straight lines. So this is not a polygon. This is. Yeah. Okay. So it should not be curved lines. Fair enough. What is a quadrilateral? What's a triangle? Triangle is polygon with 3 sides. And quadrilateral?
4 sides.
Pentagon? And so on. And parallelogram? Quadrilateral? Okay. Whose opposite sides are parallel. So you have to say, if you can prove that, you don't have to put that in the definition, because definition should be
As short as possible.
yeah. That's the important part. You don't have to say that opposite sides are equal, because if they are parallel, you can prove that they are equal, right? Rectangle? I didn't
Give the shortest.
Opposite sides are equal.
opposite sides are parallel. You said that already from polygon or parallelogram? Parallelogram with opposite sides equal. Okay. So adjacent, it's enough to say adjacent sides are equal. Because we have already said for parallelogram, opposite sides are equal. You can prove that, right? So why do you have to repeat it? It's enough to say, you can, of course, if you want.
Adjacent angles.
Adjacent angles.
Sorry, what did I say?
Sides.
Adjacent sides are
Oh, sorry. Yeah. Angles, yeah. I completely messed up, yeah. Actually, the rectangle, all angles are equal is enough, I think, right? Yeah, okay. And square? So again, you can say adjacent sides are equal. All angles are equal. Can't you prove that from the definition?
Yes.
You don't have to say it, right? Yeah. Those definitions, did they fit this or did they fit this? This one. Okay. Now we want you to give definitions assuming this one.
Okay, so what is a quadrilateral?
a polygon. Just a polygon. A polygon which is not a rectangle or a square or a triangle.
But you haven't defined rectangles and squares and so on, so you have to.
But polygon?
A polygon is
But then this is a quadrilateral. No, we only want things like this to be quadrilateral.
Yeah, this is what we're talking about. If you want this one, how will you define quadrilateral? Yeah. Okay, it's like that. Says that quadrilateral is a polygon in which none of the sides are equal and none of the angles are equal. And has four sides. Okay, so a quadrilateral is a four-sided polygon where none of the angles, none of the sides are equal. And what's a triangle? Okay, so these two we can keep, right? This we can keep, and this also we can keep. The problems arise below this.
Quadrilateral polygon with four sides we can keep. We are later with them. Quadrilateral.
Yeah, but we are keeping only this part. We are keeping this part, but we have added something.
What is a parallelogram now? By this.
It's a polygon with two sides parallel. Opposite sides are parallel.
A polygon with opposite sides parallel.
And angles are supplementary.
And?
Adjacent angles are supplementary.
So I take it that this will be a. Oh, opposite sides are parallel. Okay, I was going to draw this picture. Okay, opposite sides are parallel. Four-sided, okay. So it has to be a four-sided polygon. Have you written? Oh, you have written that.
Four-sided polygon. But so then now a rectangle becomes a polygon. Yes. That's not allowed.
With only opposite angles equal, or with opposite angles equal.
But even in a rectangle, opposite angles are equal.
But adjacent angles should not be equal.
Adjacent angles should not be equal.
Adjacent angles should not be a parallelogram. Okay. Yeah. This we are keeping. This also parallelogram. This part we are keeping, right? From this.
Now what is a rectangle?
Yeah. This part. Opposite sides are parallel.
Rectangle now.
A four-sided polygon with adjacent sides are equal.
Four-sided polygon what?
With adjacent sides.
All angles are equal. All angles equal.
All angles equal and adjacent sides not equal.
Someone wants to say something here.
Yeah. Yeah.
The adjacent angles in a rectangle are equal.
Adjacent.
A parallelogram with adjacent angles equal.
Yeah, you were saying a rectangle is a parallelogram with.
No, it's not a parallelogram. But
If you want to say a rectangle is not a parallelogram, what do you have to say about rectangles?
it's a polygon with four sides,
Yeah.
and all the angles in a rectangle are equal. And opposite sides are parallel.
But if you want to say that a rectangle is not a parallelogram,
And
what
not
do you
a
have to
square.
add?
And not a square.
Adjacent angles are equal.
Adjacent angles are equal, that will.
All angles are equal.
It can still be a square.
Yeah.
Adjacent sides are equal.
Yeah. So that's what we got down.
So let's find out four-sided polygon with
All angles equal.
all angles are equal.
No, that's one.
This is over there.
Adjacent, no, only adjacent sides. No, only.
I see. We formulated this differently. That one we formulated differently. Can we put it the same way?
But you can't put it.
Yeah, I guess. So we'll have to say all angles are equal. Yeah. But roughly, instead of saying all angles adjacent angles are equal. Okay.
Okay, square now. Something there.
Yeah, somebody here. Because we have been looking at this side now. How do you define a square?
A four-sided polygon with adjacent sides equal.
All
Four-sided polygon where all sides are equal.
But you have to make sure that the square is not a rectangle. It is not a parallelogram. It is not a quadrilateral. Oh, yeah.
So we can just write a four-sided polygon where all sides are equal.
So notice, if you compare that with this, you see how simple this is and how extraordinarily complicated, unnecessary. Pardon me?
Both are correct.
Both are correct, but this one is very simple, simplest possible definitions. That is extremely complicated, unnecessary statements. Right? So we remember that we had earlier said we should not add anything unnecessary to our definitions. Okay? So the general principle say anything that is unnecessary. Okay? Don't talk too much. This is what my wife keeps telling me all the time. And there is a word for this. This is called, not exactly formulated this way, but the spirit of this idea is called Occam's razor. There was a famous scholar in the 14th century who formulated this principle. Sometimes it is also called the principle of simplicity. Simple doesn't mean easy to understand. Doesn't mean easy to understand. It means fewest possible statements, fewest possible words in terms of number, not in terms of difficulty of understanding. It's the same thing. What it means is, if you can do something with 5 statements, do not use 6. Right? Here we show that this is possible, and here there is many more. So that violates this principle of Occam's razor. So why did we begin this class session by saying a square is not a parallelogram, is not a rectangle, and so on? Why do you think? Is it because we believe that squares are not parallelograms? Yeah.
We don't want to test our knowledge about all the...
Actually, not really. We knew you will not be able to give us the reasons. Not test your knowledge. We wanted you to learn how to reason, how to argue, how to justify, how to defend your position, not simply assert your position. Right? Initially, you said squares are not rectangles, and we said you said squares are rectangles, and we said, I get confused. Okay, and we said no, squares are not rectangles, and you said yes, squares are rectangles, and we said no, squares are not rectangles, and we keep shouting at each other. That doesn't work. Okay, that is what people do in politics. Okay, in mathematics and science and so on, that's not what we do. We give reasons to support what we think. Yeah.
So why do people believe in Occam's razor? As if we take that concept in language, if 2 people are communicating, and if we want to speak it in less sentences, then the person has to use difficult language.
Yeah.
So the other one will get confused if he is not of that level.
Yeah. So that's a very good question, actually. That goes to the very concept of simplicity in mathematics and science, and simplicity in communication. So if we want to explain something to you, we use a simple language. We should. But that meaning of the word simple is different. That doesn't mean fewest possible words.
It means easy to understand.
Easy to understand. But when scientists produce knowledge, not try to explain science to students, they use the other notion of simplicity. That is how we evaluate knowledge. But when we want to communicate knowledge to somebody else, we use the other notion of simple. So when we talk to you, of course, we should be as easy to understand as possible. But when we create science, when we create mathematics, we switch gears. Those are 2 different things. We agree that when teachers talk to students, we should not use by Occam's razor. Yeah. Any other questions? Okay, then we want to ask you a question. What were we trying to teach you? Were we trying to teach you 5 minutes, right? Yeah. Were we trying to teach you a body of knowledge? You knew all this stuff, right?
You know what a square is.
Yeah. You don't have to learn that stuff. You knew it like 20 years ago, you knew this. Nope. You didn't? You remember what it was like 20 years ago?
How do you know you didn't know it?
Okay. Yeah. So we were not trying to explain to you a body of knowledge. What we were trying to do was to help you become producers of knowledge. there are researchers, mathematicians, scientists, historians, philosophers who produce knowledge, and students are supposed to get that knowledge from above and accept it. And we were trying to teach you how to become producers of knowledge.
Producers were also evaluators of
Yeah.
knowledge, because from your textbooks, from newspaper articles you read, you should be able to see whether it's valid, which one should you pick, which classification should you pick. And there'll be various different things in your textbooks which you read where they're classifying animals into humans and other mammals and things like that. Why should you accept that classification? Why should you not accept another classification?
So when a teacher says something, or a textbook says something, you should ask, why should we believe you? Exactly the kind of stuff that we did. Are butterflies birds? No?
Why not?
Butterflies are birds because they can fly. So birds, why should all birds have feathers? Butterflies don't have feathers, and yet butterflies are birds. What's the big deal? So when you learned butterflies are not birds, you should have said, why not? And what do you think will happen? The teacher will beat you up. Huh? No, not these teachers, but if you do that in the exam, of course, you'll be in big trouble. Okay, so we have only 3 more minutes left. How many? 3 more? So ask some quick questions before she rings the bell again. That is one thing we cannot do. We cannot question the bell ringer. Everything else we can question. Yeah. Any questions you want to ask? As long as you don't ask me what my weight is, I'll answer it. Madhav can answer you his weight, right?
I don't know.
You don't know the weight?
Yeah.
Ah, okay. I don't know my weight either.
It's over 20 kilos.
Huh. Mine?
Yeah.
Yeah, mine is over 5 kilos.
Okay.
Yeah. Is that true or false? True. Yeah. He said my weight is more than 5. Oh, that's it. You didn't know that we created monsters. Why should they believe that my weight is more than 5? It should be 4. That's true. Okay. So let me introduce ourselves again. His name is Lol, and my name is Hadi. Do you know the Lol and Hadi team?
Yes.
Yeah. He is Laurel, and I am Hadi. Okay.
We did some movies earlier, you should try it.
Yeah. Okay. So, what's the? Did they get a 2-minute, 5-minute break or what?
They get a 15-minute break.
15 minutes?
Yes.
Oh, okay. What do they do in 15?
Well, if they have any questions for any of us, they can ask.
Okay. So, questions for all of us or
Or if
questions?
they want to stand up and sit down and do some exercise, they can.
Why don't you guys introduce yourselves then? During those very quickly, so that they know what is in store for them.
Okay. I'm just going to write Surprise, 10 to 10:45?
The break is
be surprised anymore.